Alright, in this video I'm going to be working some linear approximation examples. I'm going to be working through BC Homework 4.2. So we're going to start with a linear approximation centered at 2 to estimate y of 2.14. And so we'll need the tangent line, and then we're just going to plug in 2.14 to find, an approximate value for y. Alright, so I'll say point is going to be x is 2 and y is, or t is 2. And y is going to be 2 times 8 is 16, minus 6 times 4 is 24, 18, minus 24 is negative 6. So the slope is, or y prime, equals 6t to the 2 minus 12t to the 1. And y prime at 2 is going to equal, 6 times 4 is 24, minus 24 is 0. Okay. Okay, looked at the key I had from last year, and I got the same thing. So, all right, the slope is 0, and so the equation is y plus 6 equals 0 times x minus 2. And, what's going to happen is no matter what we put in here, the approximation is still going to be negative 6. So my approximate value for y at 2.14 is still going to be negative 6. That kind of makes sense, right? If we have, I don't know if this is at a, hold on. Yeah, it's at a relative minimum. So, if we're here and the slope is flat and we're concave up, then, the linear approximation is just going to stay the same, right? Because the line is just constant. All right, over here. G of 1 is 3 and G prime of 1 is negative 3. Use linear approximation to estimate G of 1.25. All right, the tangent line is going to be y minus 3 equals negative 3 times x minus 1. And, maybe to get ready to do a linear approximation, I'll add that 3 to the other side. Okay. So I'll say that G of 1.25 is approximately equal to 3 minus 3 times 1.25 minus 1. Okay, that's going to be 3 times 0.25 is 0.75, and if I'm subtracting that from 3, that would be 225. All right, use the line tangent to the graph of h to estimate the value of h of 3.2. All right, well, given the x values I have, okay, hold on just a second. Yeah, this one's a little bizarre. I'm not sure why I put this one on here. Okay, we don't have any information about h prime, so we're going to have to give it our best guess, which is going to be, the slope between 2 and 3. I wouldn't choose 3 and 8 or 2 to 8 because those intervals are super wide, right? I think that interval 2 to 3 is narrow enough that I can get a decent approximation for the slope of h at 3 by doing the difference quotient there. So I'm going to say h prime of 3 is approximately equal to negative 1 minus negative 4 divided by 3 minus 2. And then that's okay, that's 3 over 1, and that's 3, okay? So y minus the y coordinate at 3, so y plus 1 equals 3, positive 3, times x minus 3. And this is strange. Okay, so y equals negative 1 plus 3 times x minus 3. Okay. So if I wanted to approximate h of 3.2 using this tangent line, which isn't, I guess, even a tangent line, I suppose it's a secant line, what is the best we got, is approximately equal to negative 1 plus 3 times 0.2. Okay, so negative 1 plus 0.6 is 0.4. Negative. All right. Let's get to, here's some good regular ones. So f of 2 is 3, and the graph of the derivative of f is pictured at right. Okay, so this is f prime. All right, use a linear approximation, so I'm going to need a tangent line. Oops. Okay, so I'm going to center my approximation at x equals 2. Right? So y minus, and what is f of 2? F of 2 is 3, is equal to the slope is going to be f prime of 2, which will be right here. So the value of f prime when x equals 2 is 3, so that's the slope times x minus 2. And I'll just even write in that f prime of 2 equals 3 from that dot right up there. All right, now I'm going to estimate f of 1.9. 3 plus 3 times 1.9 minus 2. And f of 2.1 is approximately equal to 3 plus 3 times 2.1 minus 2. And that's far enough in this situation. Okay, are my estimates in part A greater than or less than the true values of f of 1.9 and f of 2.1? Okay, we know that has to do with kind of the curvature of the function of the concavity. So what I'm going to say is that pretty much for all x, it appears like f prime is increasing. So I'm going to say f double prime of x is greater than 0, at least for, clearly near 2. Okay, so let's say 1 to 3. But it appears to be true everywhere. I think this is an exponential function. So, since it's concave up, what's going to happen is the tangent line is going to underestimate the true value, right? Because this is the line and this is, f. Meaning that if my tangent line approximations were down here, they are less than the true values. Okay. That's what I'll say for that one. All right, find the linear approximation for cosine of x at x equals pi over 6. So I need a point, and it's going to be pi over 6 and cosine of pi over 6. Okay. Pi over 6 is the short one. It's got a 30-degree reference angle, so if it's a 30, 60, 90, this has length 1, this has length 1/2 because it's the short leg, and this has length root 3 over 2 because it's the longer leg. And so the cosine, SOHCAHTOA, adjacent over hypotenuse is root 3 over 2. So pi over 6 and root 3 over 2. Okay, the slope is going to be f prime equals negative sine x. So negative sine of pi over 6 is going to be negative 1/2. Okay, so the linear approximation is y minus root 3 over 2 equals negative 1/2 of x minus pi over 6. Use the linear approximation to estimate the values of cosine of 1/2, cosine of 3/4, cosine of 1, and cosine of 2. Which estimate is the most accurate? Are they overestimates or underestimates? Right, that's kind of a lot. I'm bringing in some more paper here. And I can slide that up because that's all we need is the tangent line equation. All right. So I'm going to say cosine of 0.5 is approximately equal to root 3 over 2 minus 1/2 of 0.5 minus pi over 6. And, I mean, you could distribute that if you wanted to, but I don't really feel like it. So cosine of 75 is going to be root 3 over 2 minus 1/2 of 75 minus pi over 6. And I know of a problem that's a linear approximation of a trig function that's much nicer than this. I don't know why I didn't put that one on there. Yeah, at one point was putting that on the quiz. Cosine of 1 is approximately equal to root 3 over 2 minus 1/2 of 1 minus pi over 6. Cosine of 2, that's really far away from pi over 6, right? Because 1 radian is up by pi over 3, so this is just way too far away to even be using a linear approximation, but it asks for it, so I'll give it to it. Root 3 over 2 minus half of 2 minus pi over 6. All right. So which estimate is the most accurate? Well, pi divided by 6, pi is just a little bit bigger than 3. So it's just a little bit bigger than 1/2. Okay? So I would think that this one would be the most accurate because it's closest to the point of tangency. And we know that the graphs of sine and cosine are pretty curved. So, farther away we go, the more it's curved away from the line, the linear approximation, and the less accurate your estimate will be. Overestimates or underestimates? Well, okay, the second derivative is going to be negative cosine, which up until pi over 2 would be negative because cosine is positive over here. Okay, so up until pi over 2, it would be concave down, which means that they'd be overestimates. But you can't say that for x equals 2 because we experience a change in concavity here at pi over 2, and pi over 2 is between 1 and 2, is what I'll say. Okay. But it's another strange one. I'm not the hugest fan of this homework so far. It might need to be rewritten. So here, this is more like it. Use linear approximation to estimate f of 2.1. All right. So point would be 2 and 4 minus 32 plus 12. So that's negative 28 plus 12 is negative 16. Okay, whatever. Slope f prime is 2x minus 16, which at x equals 2 is going to be 4 minus 16 is negative 12. All right. So the line is going to be y minus negative 16 equals negative 12 times x minus 2. Approximate f of 2.1. I made that. Negative 16 minus 12 of 2.1 minus 2. I'll just leave it like that. Okay. Use a linear approximation at x equals negative 1 to estimate the value of f of negative 1.1. That was 2x to the 2 minus x to the 4. So f of negative 1 equals 2 times x squared is 2 times 1 minus x to the 4th is 1. So 2 times 1 is 1. Okay, the slope f prime of x equals 4x minus 4x to the 3. So f prime of negative 1 equals negative 4 minus 4 times negative 1. So 4 plus 4 is 0. It's the second time the linear approximation has been with a flat tangent. It's disappointing. Okay, so the linear approximation is going to end up being 1 again, but I'll say, okay, y minus 1 equals 0 times x minus negative 1, and then f of negative 1.1 is approximately equal to 1 plus 0. Okay, so it's 1. Consider the curve defined by negative 8x squared plus 5xy plus y to the 3 equals negative 149. Find dy dx. We just learned how to do that. So that's negative 16x plus 5xy. All right, I'm going to, let's see, if I want to find dy dx, if I factor out the 5, I'm going to have to redistribute it later. So I'm just going to look at this as 5x multiplied by 1y. So I'll take the derivative of 5x first and leave y the same. Then I'll add in, leaving 5x the same, taking the derivative of y with respect to x. That's dy dx. Then we're going to take the derivative of y to the 3 with respect to x, and that's 3y to the 2 dy dx. And the derivative of negative 149 is 0 with respect to any variable. So I'll factor these out. Move that to the other side, and so I'll have 16x minus 5y divided by 5x plus 3y squared. I wouldn't normally skip the algebra steps like that, but I just didn't have room to fit them. Write an equation for the line tangent to the curve at the point where x is 4 and y is negative 1. All right, well, I've got a formula for dy dx, so that's helpful. I'll just compute that over here. dy dx at 4 and -1 is going to equal, what is it going to equal? Okay. 16 times 4 is 64, plus 5 is 69, divided by 20 plus 3. Okay. Oh, and that's going to be 3. All right. And I think this is an old free response question, so it's not surprising to me the numbers worked out nicely. And so I'm going to write the equation for the line tangent. It's going to be y minus -1 equals 3 times x minus 4. All right. So there's a number k for which the point 4.2 and k is on the curve. Use the line found in part B to approximate k. All right, well, I'm just going to plug in 4.2 for x and k for y. So k equals -1, 3 times 4.2 minus 4. Okay, so that would be -1 plus positive 0.6 would be -0.4 again. Write an equation that gives the actual value of k and find the value of k with technology. Okay, well, that's, all right, x is 4.2 and y is k in this equation. So I'm going to just say -8 times 4.2 squared plus 5 times 4.2 times k plus k to the third equals -149. Okay. Well, -8 times 4.2 squared plus 5 times 4.2 k, I'll use x, plus k to the 3 equals -149, so I'll add 149 to both sides to hopefully find a 0 that is near -0.4, okay? So I'll zoom standard. I have faith. It'll be near 0. Yeah, there it is. Okay, great. So I'm going to calculate the 0. Left bound looks like -1. Right bound looks like 0. Give it a guess. -0.372 or -0.373. Okay. Find the difference between the approximation and the true value of k and determine the sign of the second derivative. Now that's a good question. I like that one. So, since k is greater than the approximate k, which maybe I'll throw a hat on that one to remind us that it's an approximate k. Those of you that have taken the statistics class, you've probably used the hat for an approximate value before. So since the true value of k is greater than the approximated value of k using the tangent line, I gotta think, okay, so the curve is sitting above the tangent line, okay, regardless of which way it's oriented. That means it's concave up, so I'm going to say the second derivative is going to be positive. Okay, I really like that. This homework's got a variety of problems. Some good, some less good. All right, for g of x equals secant of x, find an equation for the line that best fits g at pi over 3 and approximate g of pi over 3 minus 0.01. Okay. Let's see. G of pi over 3 is equal to 1 over cosine of pi over 3, because that's what secant is. Okay, so I'm going to need to kind of draw my triangle at pi over 3. Pi over 3 sits at that 60-degree reference angle, so it'll have hypotenuse 1, long leg root 3 over 2, and short leg 1/2, just like all 30, 60, 90 triangles that have hypotenuse 1, or that are on the unit circle. And I know that cosine in this situation is 1/2, so katoa, and so secant will be 1 over 1/2 is 2. Then the slope will be g prime of x. Who knows, maybe you had to go look this one up. Maybe you had to go tune into this video to be reminded that the derivative of secant of x is secant x tangent x. Okay? We need to start learning that. Time is coming pretty soon where we're going to be expected to know that. And so g prime of pi over 3 is equal to secant x. We already did secant of pi over 3. That's 2. Tangent is SOHCAHTOA. Okay, opposite over adjacent. Root 3 over 2 divided by 1 over 2 is root 3 divided by 1. Okay. So my equation is going to be y minus 2 equals 2 root 3 times x minus pi over 3. Okay. So the approximate value for this number, this is approximately equal to 2 plus 2 root 3 times, okay, pi over 3 minus 0.01 minus the pi over 3 is just going to be negative 0.01. I'm just going to leave it just like that. All right. Write the equation for the line tangent to the graph of f of x equals 1 plus tangent x to the 3/2. Okay. Use it to estimate f of 0.02. I'm just going to assume that this means at x equals 0. Right. I think that would make sense. We can compute f of 0 pretty easily. That's very near 0, so I think I just meant to type that in. So the point, make sure I'm still in the shot, is going to be f of 0 equals 1 plus tangent of 0. Okay, over here, x is 1 and y is 0, and tangent is sine divided by cosine, so it's 0 divided by 1 is 0. And that's going to be 1. Okay, the slope f prime of x, I'm going to use the power rule first because it's on the outside. It's going to be 3/2 of that thing to the 1/2 multiplied by the derivative of the inside is the derivative of 1 plus tangent x. The derivative of 1 is 0, and the derivative of tangent x is secant squared x. F prime of 0 equals 3/2. We already know that the thing in parentheses is going to end up being 1, and any power of 1 is just 1. And secant squared x, okay, well, cosine of 0 is equal to 1, because the x-coordinate's 1 over here. And secant is 1 over cosine, so it's 1 over 1, so this is going to be 1 squared. Okay. So it looks like this is 3/2. Right? The tangent is y minus 1 equals 3/2 of x minus 0. And then my approximation is going to be f of 0.02 approximately equal to 1 plus 3/2 of 0.02, which is going to be 1.03. All right, here's a nice little table problem. Maybe I'll zoom out so we can see all of it. Write an equation for the line tangent to the graph of f at x equals 3. All right. Point is going to be 3, negative 1, so y plus 1 equals, the slope would be 4 times x minus 3. All right, then I'm going to say, I know I'm going to use it, so I'm going to negative 1 plus 4 times x minus 3. All right, so approximate f of 2.9, I do that. It's approximately equal to negative 1 plus 4 times 2.9 minus 3, which if you're on the quiz or the free response section of the test would be a perfectly fine place to stop. But, you know, maybe I'll just actually do the computation, because on the multiple choice section, you're not going to be able to just stop there. You're going to have to figure out what it is. So this is 4 times negative 0.1 is negative 0.4, minus 1 is negative 1.4. All right. Which is greater, f of 2.9 or my approximation for f of 2.9? Well, f double prime of 3 is less than 0, meaning it's concave down, even if the slope is 4. And I was over here at 2.9, which is a little less than 3, which is greater. My approximation is greater. last page of problems we got is, okay, h is a solution to the differential equation with h of 1 equals -5. All right, if you are, well, if you're watching the video this far, I'm just going to tell you that at least these two parts of the problem, okay, and this is supposed to be x equals 1. This is just bad. I have a feeling that I went back and changed this on the original Word document and did not resave it as a PDF and order the bad copies. Yeah, because h of 1 equals -5. We're going to have to, we don't know what h of 0 is. Okay. What I was going to tell you is that the free response section of the test in this unit is going to be, it's going to be a problem like this, where it starts off with a differential equation, and you will find the second derivative implicitly. You will write an equation for the line tangent and use it to approximate a value. You'll determine if it's an overestimate or an underestimate. This is kind of a backwards version of the same question. And then you might be asked about a maximum minimum situation. So, all right, write an equation for the line tangent to the graph of h at the point where x equals 1. We can do that. So y minus -5 equals dy dx is going to be at 1, -5 is going to be, so -4 times -2 is +8. And that's going to be y equals -5 plus 8 times x minus 1. Okay. So use the tangent line to approximate h of 0.9. That's going to be approximately equal to -5 plus 8 times 0.9 minus 1 is -0.1. So that'll be -5.8. Okay. It is known that h of 0.9 is -5.910. Based on this information, is h concave up or concave down in the neighborhood of x equals 1? Okay. I'm just going to, especially since they're both negative numbers, I'm just going to lay them out and just like be real clear about which one's greater. This one's greater because it's closer to 0. Okay, so since the approximation is the one that's greater than actual h of 0.9, it was an overestimate, which means that in the neighborhood of the point of tangency, it's got to be concave down, okay, based on that drawing. So I'm going to say h must be concave down. And my reason is this, that the approximated value is greater than the true value. Okay. Okay. The linear approximation for f of t at x equals 4 is y plus 2 is -1/3 of x minus 4. What is the value of f of 4? Well, it's the y coordinate of the tangent line, right? That's what it means to be tangent, is it's at the point. So at x equals 4, y equals -2. What is the value of f prime of 4? F prime of 4 is the slope of the line tangent to the graph of f at t equals 4. Oh, whoops, this looks like this is supposed to be an x. Oh my goodness, the typos on this one are just atrocious. That's all right. So I'm going to say f prime of 1/4 is the slope of the tangent line is -1/3. And if f of 3.7 is -2.04, determine the sign of f double prime of 4. This is another backwards question. Got some good versions of this kind of backwards question to figure out the second derivative based on the approximation, but some of the other problems on this homework were very lacking. This is a good one to end on, though. So f of 3.7 is -2.04. So we're going to need to approximate f of 3.7 using the tangent line. No, 3.7. Well, I'm going to say the approximation is equal to f of 3.7 is approximately equal to this, but we actually know what it's equal to. So I'm going to say the approximate value of f at 3.7 generated using the line tangent is going to be -2 minus 1/3 of 3.7 minus 4 is -0.3. Okay, 1/3 of 0.3 is 0.1. So -2 plus, yeah, because that's going to be a plus of 0.1 is -1.9. Okay, now in this situation, oh, again, just like before, since the approximate value is greater than the true value of 3.7. Right, yeah, negative 2.04 is more negative than negative 1.9, so negative 1.9 is greater. That says that f double prime of 4 has got to be negative, right, for the same reason as up here, because the tangent line was an overestimate. Anyway, that's all for this video.